Notebook?
Just your notebook.
Could you pass me that? It's right behind you.
Get out of the frame! God!
Thanks. What?
Watch the camera. Get out.
Totally targeting.
Go.
But if I
And you should ears away, headphones away.
Wait,
Your eyes and ears.
Hey.
Hey.
It's like you're, I'm gonna lose 1 million views because of that.
Yeah, I told her that. I was like, you're in frame.
It's gonna be an unlisted video.
Yeah. Are you YouTube famous, Andy?
Why?
You got subscribers on YouTube?
I got one video with like 100 views.
Wow.
So
Oh my goodness.
All right, so
Do you actually post these on YouTube?
yeah, but they're unlisted.
I don't know what that is.
You should list them.
Andy Academy.
Wait, I want to go watch them. Yeah. What are they called?
I have a lot of videos from my high school cross country. I used to.
Oh yeah, we.
Oh no.
I was really into film back in the day. Okay, so the objective today is we're gonna learn about the concept of standard deviation and normal distributions. Give me a nod if those words sound familiar to you. Okay, so if you're here last year, you did a unit with Tori on this stuff. I'm assuming today that we forgot everything. So I'm going to teach this like you've never seen this before. All right? All right, so a normal distribution. This is like the most useful tool that we use in statistics. And it's a way of modeling data. And what I want you guys to draw first in your notes is we'll title your notes normal distribution. And I want you to draw this bell curve here and break it up like this. And then I'm going to pick on Braden because he's in calculus.
What? No.
You are drawing the most beautiful bell curve ever today. Right here. Braden, question. In calculus, you're doing integrals, right?
Yes.
What do integrals tell you?
They tell you the area under a curve.
The area under the curve. In this case, this is how we use the bell curve. What we care about is the area under the curve. And what the area under the curve represents in this case is the probability of my result or individual data point being between an interval. So what I'm going to write here is the area under the curve represents the probability of getting a result between two intervals. And this little symbol, B/W, this is something that Lori taught me. She taught me how to take fast notes.
Black and white?
But that just means between. B/W means between. So I might do little shortcuts sometimes when I'm lecturing because writing is hard. So between two intervals. That's the main thing that is important about these bell curves, or what we call the normal distributions, is we care about the area under the curve. It represents the probability of a result between two intervals. All right, so bell curves can look different. They can be different. Some of them can be fat. Some of them can be super tight, thin, like little tiny bells and fat bells. What that measures is how widespread the data is, or data are. I think it is words. So if I have a really fat bell curve like this, go ahead and draw these two bell curves. If I have a really fat one, the thing that tells me is the more widespread the data is, or the more spread out the data is, the fatter the bell curve. What I mean by more widespread is a tight data set means that most of the data values are really close to the mean or the average. A widespread data is all the numbers are more varied. They're not all close together. There's more variety in the data. And so the tighter the data is, the thinner the bell curve. So are you blocking my video?
Are you really videoing this?
Yeah.
Where am I gonna take notes now?
Videoing this.
I guess I should have sat next to Leela.
Right next to me.
Okay. Do we have this?
No.
Wait. I can't see it.
Like I don't even think I have a
This
pencil
one?
handy.
Is a big fat bell, and under it says the more spread out the data, the fatter the bell curve.
So I have to write all that stuff down.
Unfortunately.
And then this one is a really
Unfortunately,
thin
what?
bell, and it says under
Wait.
it, the tighter the data
see your
is, the
song?
thinner the bell
It
curve.
looks so much different.
Yeah, fake ID after school.
Huh?
Nothing, I'll tell you later.
My room is so
Dude.
small and there's too many of us.
That's so weird.
I know, man.
Show Toby.
Guys, I haven't tripped
Toby.
yet. This is a miracle.
Toby.
Hmm?
Look at her. No. Look at her teeth, bro.
I'm so excited.
Yeah, that's what I'm saying. She looks different.
Oh, yo! I'll get mine off in a month.
Thank you. All right. Next, I want you to draw a new bell curve. And right now, we're gonna label this thing with a bunch of stuff. 4. All right. This center of the bell curve. Does anyone want to give me a gander of what the center of the bell curve represents? Great. The mean.
How would any of us get to know if Brayden's already in calculus and already knows this stuff?
This is not calculus. This is
Yeah.
Thank you for helping our
He
learning.
still already knows this.
No.
I need to. I go get a
No.
chair.
You can go after I'm done. There's a chair right
If I
there.
keep myself in your classroom, that's on you.
Your bladder only
Okay.
tells you have to pee when it's half full. It's never.
So the
that's
center of the
only
bell
when-
curve is always the mean of our data. And then if I go out one line
Why
over,
are you staring at me?
this represents one standard deviation. And we're going to talk more about a standard deviation, but basically what it measures is how spread out the data is. And so this distance right here is what we call one standard deviation. And I'm using a special symbol. That means standard deviation. So this line right here is one standard deviation.
But that sign means standard deviation?
What is
Yes.
that? I can't even see the sign. No.
Yeah, what does the sign look
The
like?
sign looks like this.
Oh, okay.
That's fun to draw.
What? That was all already written.
And so this line is one standard deviation. This line is two standard deviations away from the mean. And one thing I want to emphasize is a standard deviation is a distance on the bell curve. It's a horizontal distance.
Oh. Okay.
So this distance right here is one standard deviation. This distance right here is two standard deviations.
Right.
Similarly, this is also minus one standard deviation.
When did we learn this? Because I've totally learned this before.
You learned it last year.
Oh, perfect.
But I'm assuming you guys like forgot everything.
Yeah.
So I'm teaching it like you've never seen it before.
I mean, we really didn't retain much information last year.
It was hard, you know, like being online.
Do you think colleges are going to be more understanding about stuff like that when they see, like...
For sure.
You think
They
so?
See my fucking 1.0 GPA.
Give me my virgin ears, please.
Yeah, dude, there's a camera guy.
All right. What did I say? What do we care about the bell curve again? Like, what did I say earlier?
Like the significance of a bell curve? Or...
This,
No.
Oh, that's a single standard deviation.
Did it
Or the
spell?
flatter the bell curve, the more spread out the data.
No, mine doesn't have
okay, sorry. Let me backtrack here. I care about the area under the curve.
Is it on
And
the
so,
outside?
one thing I want to highlight here,
Oh, it's all
is-
in my bag.
for every single bell curve I have, this is always true. These proportions are always true. So this area under the curve, from here to here, is always 34% of the data. Always. Similarly, if I go over 1, this is also 34% of the data. This right here, this little tail, that's going to be 13.5% of the data. And that's the same on this side too.
Yeah.
And then right on the tail here, this is 2.5% of the data. And if I come over here, I'm going to also label it right there. So, properties of the bell curve. Right now I have like blank of the data are within 1 standard deviation of the mean. What do I mean by that? 1 standard deviation of the mean.
Like 34%.
This is 1 standard deviation of the mean. This is also 1 standard deviation of the mean. So if I take this area and that area and add them together,
Oh.
always 68% of the data are within 1 standard deviation of the mean. Write this down, this is important.
What?
I do expect you guys to have these percents memorized for a bell curve. Similarly, if I go from 2 standard deviations of the mean, so I'm talking about from here to here,
95.
95. That represents 95% of the data are within 2 standard deviations of the mean.
Whoa. That's crazy.
You think?
No.
And so I'm gonna just add a little label to my picture here, and I'm gonna call that 68%. And then from here to here, I'm gonna put 95%.
Okay, so no matter what, always 95% of the data will be within 2 standard deviations of the mean.
Always.
Always?
Always.
Okay. That does
Yeah.
not matter with anything.
Whatever bell curve, if it looks like this,
Yeah.
it's always gonna be like that.
Okay.
Assuming it's a,
Or if it's super fat, it's always gonna be like that.
assuming it's a perfect bell curve.
Assuming it's a person.
And one thing that's important, Brayden, if I take the integral of this from negative infinity to positive infinity, it's 1.
For 1, yeah.
You need help.
Because it's probability, and probabilities are from 0 to 1.
Yeah, makes sense.
That's why it's important to take calculus.
You going over there now?
I'm going over here now.
Are we
Alright.
still taking notes?
You are still
So I'm
taking
gonna put my
notes.
butt in your face for a second.
Everything I've written on the board over there, you should have in your notes. All right, I want to talk a little bit more about standard deviation and how to calculate it. So if I have a really big standard deviation, what does that tell me about the data?
Oh no!
It's really spread out.
Am I in it?
A really tiny standard deviation means the data is really tight together. meaning that most of the data points are really close to the mean.
No, it's Andy's.
So standard deviation, it tells us how spread out the data is. So we have a
Is this
formula
good?
for standard
Is that good?
deviation, and it's this. And you may be looking at this and be like, Andy, why are you trying to kill me?
Dude, what is that?
Yeah.
Why are you throwing ancient Greek at me?
Oh,
Oh,
no,
Nico.
no.
Are you
This-
gonna dress up for Santa?
Duh.
It's just a bunch of symbols.
What's the
And I
thing?
want you to look at this and
Mr.
be like,
Formaggio,
hey,
do
like,
you want to be Greek gods?
it's like
Yeah,
learning a
Andy and
new
Nora are gonna
word.
be Greek goddesses.
I don't have
if I
the
don't
body
know what
to be a
that
Greek
word
god.
means, I won't be
It's
able
not
to
gonna work out.
understand
It
it.
doesn't make sense
Each
if I don't
little
have fucking
symbol in here
massive
is its
biceps.
own
I'm
little
like,
word.
you know,
So what
I can try.
these symbols
I'm
mean
just gonna
is
be the fat Greek guy.
that symbol right there.
Deal.
Standard deviation.
That's our symbol that represents standard deviation.
Depends though. We'll see.
So for sure.
Yeah.
Or STD for short.
N,
Rated.
I'm not even joking either. That's the implementation.
Rated.
N stands for the number of data points. Not what the data points are, but the number of data points, like sample size. So this is the number of data points. And I will put in little like
Who decided
brackets,
these
sample
things?
size.
Who decided that like a squiggly pointy E is gonna represent something for math?
Dude, who came up with math in the first place, though? Like,
The Wellmans.
I'm sorry, it is not my fault. Don't
Andy, this is all on
Well,
you.
it's not concepts, but everyone's like knows, hey, look at those. Those are two things, and now I ate one, and now there's one thing. It's
Wow.
just
Wow.
how humans work.
I'm gonna come back to this symbol, but I want to talk about this symbol really quick.
No.
Wait, I have the mask.
This symbol looks
rub a
really
new one.
scary. It's just like E symbol.
It looks like an E that's gonna bite your hand off.
May, do you remember what this means? Talked about it in college algebra.
I remember how to use it. I don't remember what it means.
All this tells me is add stuff.
Add stuff.
Just stop.
What do you mean stuff?
We call it a summation symbol, or epsilon if you want to be fancy.
Well, why don't you just like that's part of the group? Dude, why don't you just put the plus sign?
Oh my god, Avery.
A plus sign.
Yeah, that's the same thing. You add
Kind of.
stuff.
But what this symbol means is like, hey, we're adding up the stuff here. So if I have an example here,
I can't even draw that.
Can you?
okay,
How
the
do
way
you
you draw it,
draw
I'll
this
draw it. I'll
symbol?
You
draw it.
draw a sideways M, and then you add two lines to the.
You draw a little like thing like this,
Yeah.
and then you draw like a backwards inequality sign,
I got it.
and
It's
then
still
you're like,
looking weird though.
Or
This
we
looks funny.
or if you're kind of just scribble on the board manually.
And did you know these were both today?
no. I know some of them, like epsilon. So
That's how I do my
what
capital
this tells
E's and-
me is this little I equals 1, that's what my starting point is, or what we call the index. So this right here, I'm just going to call it the starting point. And that's always given to you.
But it can be the index too? Or is that what it's called?
Or the like fancy name for it is the index.
Coolio.
And then N I talked about. That's the like our
Number.
sample size or the number of data points we have. And then this right here, you can think of this as the rule for how I'm gonna be adding up this stuff. And so, for example, if we have N be 5, meaning there's 5 data points, the way I can think about this is I'm always gonna start at 1 and apply it to that rule. So this is really saying 1 plus, and then this thing goes up by 1 value. So if we go up by 1 value, we're at 2. 2.
3.
And then I'm gonna go up 1 again. What this says in symbols is, hey, take the sum from 1 to 5. So 1 plus 2 plus 3 plus 4 plus 5. That's what that summation symbol is telling me. I can have a different rule here. If I put a squared here, that's saying Alright, take 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. Does that make sense how that works?
Yeah.
Great.
Yeah.
Definitely not.
Why would you say no?
So this thing right here is saying we're going to take some of our data points, subtract it, square it, divide it by n, and then at the end take the square root. This right here, this regular x, that represents my individual data point.
The point we're focusing on?
Like, if I'm trying to find the average height, that individual data point would be like my height is 5'7". Or someone else's height is 6'5".
So if that's like the focus of like when you look at it and you focus on one? Is
It's
that
an
like
individual data point. And then this right here, this x with the line over it, that's always the mean or the average. Average. Can Andy write sideways?
No.
Not terrible. That's like a C. Passing.
I wouldn't pass you with that.
No?
Okay. So that's the mean or the average. And so the steps I'm going to do to calculate standard deviation will always go like this. So the first thing I need to do is I need to find the mean. I'm going to be bouncing back and forth between this board and this board. So,
Alright.
Kaylin, if I step on you, I'm sincerely sorry.
I'm moving this. I'm getting...
Below on your paper, below this section, write out this. So I need you to write this table in, and then draw a new bell curve here.
Wait, below which section?
I'm gonna have
Below
to
that
start a
one.
new page.
Or if it's on a new page, that's fine.
Andy, where am I supposed to put this when you're going back and forth?
Just move it.
I'll just hold it. I'm just gonna follow
That's
you.
why you got
Follow me
hired
around.
to
Yep.
do this.
Yep,
You didn't get hired, you're getting forced to.
Andy. This is pretty informational.
Why did the
Lock
day
the
I have to
table.
learn new things be the day I didn't get any sleep?
That is not my fault.
I'm not saying it's your fault, it's just slightly irritating, but.
Andy, could you try to work like on this side?
With this.
Yeah, I'm just trying to figure out how you're gonna get both of the boards in there.
You move the camera with them.
I don't wanna do that.
Well, you have to do it.
If you wanna do it, Lou, you can. I don't really feel like it.
Alright, so your data points should be 5, 8, 10, 14, and 18. No,
Figure it out.
we can go once I
Mine
on
look-
your time, which will be 5
Puppy!
minutes. So, I need to find the average of these numbers. How do I do that?
What?
Find the average of those numbers.
With this new thing that we just learned?
How do I find the average?
Oh, you add them all up together and then you divide them by how many there are. Boom, pow.
Yeah. So I'm going to do 5 plus 8 plus 10 plus 14 plus 18 divided by
5.
5.
Which is 11?
11. Our mean is 11.
Okay.
All right. Our next step for calculating standard deviation is we're going to find the difference between each data point and the average. And the mean. I'm going to call it the mean because that's the cool way to say it. That's step 2. And I have it written in this column right here. That's where we're going to find for step 2. This is step 2, this column. So I'm going to take 5, subtract 11, and that gives me -6. See what I did there? And then I'm going to take this data point, 8 minus 11. That's -3. And then I'm gonna keep doing that all the way down. So I'm gonna take
Negative
10
2.
minus 11, negative 1, 14 minus 11,
I thought it was 8.
and then 18 minus 11. Sweet. And then our third step for calculating standard deviation is we're going to square the differences. If I can spell square. What I mean by that is these numbers we got right here, we're going to square them. So I'm going to take negative 6 squared, which is
36.
good. And then I'm going to take negative 3 squared,
It's 9.
9. And I'm going to take negative 1 squared, which is just negative 1 times negative 1, positive 1. And then we're going to keep doing that.
Three times 3 equals 9 though, right?
Yep. I knew that.
Yeah, math teacher Andy.
That person wants to degree to teach us.
Cool. I'm gonna start calling you that, math teacher Andy. Just
Just math teacher Andy.
math
Yeah,
teacher.
math teacher Andrew.
That should be your YouTube name.
Yes.
Math teacher Andy?
Yes.
That'd be so weird.
No, dude.
No, it's perfect.
Welcome back to Math Teacher Andy.
Alright, so we got the squared of the differences. And then what I'm going to do
When am I
is
ever
I'm
gonna
going to take the average of the squared differences.
We should make an outro for Andy's YouTube.
That's the outro. It's just always saying, when am I ever gonna use this?
That's perfect.
Well, like really have to use
I
it.
said take the average of step 3. Hopefully that makes sense.
Yes.
We're taking the average of those numbers. And so what I'm going to do,
Now you add up all of them and then divide by the number of them and then get it.
yeah,
So it'd be 36 plus 9 plus 1 plus 9 plus 49. Divide by 5.
Braden?
Oh no, I'm not doing that.
Do it,
Yeah,
Brandon.
maybe, okay, so it's 19,
No one else figured it out.
8.
We'll figure it out in 10 seconds.
Andy,
Yeah,
you're so proud of yourself for
174.
beating Brayden, even though you did.
Alright.
it.
104.
well I did it ahead of time.
Yeah.
I cheated because I used decimals.
Oh, okay.
Doing that in your head's hard.
I am not sure that's right.
It's
Yes.
20.
Because I mean, the top would have to be 100, which it's not. Yeah, you did your math wrong, Andy.
Are you kidding me?
Did I?
Potentially.
Yeah, it's 104. So it's 104 divided by 5, so it's closer to 21.
Yeah.
Sure.
Definitely knew that one.
Okay.
Yay.
Brayden, if you're right, then I owe you candy.
Alright, deal.
If you're wrong, you have to do 5 push-ups.
Deal.
Now I want Brayden to be wrong. I know he's not, most likely, but I still. Anytime someone does push-ups, is funny.
I mean, technically it's 20.8. That's what I got.
It's 104, I'm telling you.
But it was 104 when you added them
I
all up.
have no idea what you guys are talking about.
Why am I so excited for this?
Andy, I really need to use the bathroom. Can I go now? I understand this.
It should be 20.8.
That's what I
Yeah,
said.
see?
I understand it. Can these guys?
Scratch the back of your calf, you won't
Yeah,
feel
you owe
like
me
that.
candy, Andy.
Okay, the last step, take the square root. So I'm going to take the square root of that, take the square root of that, and that gives me the standard deviation, which is,
Are you coming back?
I don't know.
wait, oh yeah, Lee, you talk to me.
Hey, loser,
Okay.
bye.
Okay, bye.
4.56.
Are we? We're still doing this. Okay.
What did you think was happening?
Well, I
Yeah.
thought we finished.
We are not done yet.
Are we still not done?
Oh yeah.
So,
We're never done.
so what I can take from this is I'm gonna go to my bell curve. This number here is gonna be the average, which is 11, right?
I didn't even
That number is 11. This number right here, horizontally, is what?
Don't throw them out.
It's 1 standard deviation away from the mean.
Yeah.
1 standard deviation is 4.56.
So it would be 15.56.
You think?
Yeah.
Yeah, 15.56.
15.56.
I said
What would
that.
this number be? You can give
Ni-
me like the adding formula.
It'd be 15.56 plus 4.56.
Or
9.
11 plus 2 times
Oh.
4.56.
Like,
Because
Well, you
it's
could do
2
that.
standard deviations away
Yeah.
from the mean.
So what is it?
0.012.
It's like 20.
20.012, yeah.
Yeah. This one would be
Because you have to minus.
yeah, because we're going in the opposite direction. And then this one would also be
Andy, why are we doing this on a Tuesday morning?
Because you can't teach this in Tuesday afternoon.
and that's what I have for you guys with standard deviation and bell curves.
Is that all?
We have about 15 minutes left in class.
For free time.
I need you guys
Oh.
What?
Andy,
Oh,
no.
no.
Stop. No.
Oh,
No.
no.
Tomorrow.
grab this assignment
Tomorrow.
and start this
No.
assignment.
No. Please.
Andy,
All right.
please.
Come on up and grab it. You can stop the video now.
Okay.
Why are you like
Andy, I have a present for you.